Okay, so again, a little bit more deconstruction. So we're looking at something called a method call. You're calling a method. You're asking the computer to do something. And a method is a bit of functionality that you can call to do complete a certain task. That's called a method call. A method call requires a few things. First thing, you have to specify the object you want to call using that method. So in this case, the object we're using is called system.out. The next part of a method call is the name of the method you want to call. In the example above, the method is printline. Sometimes people mistake the L in line as the number 1. That's not the number 1, that's the letter L. And this command comes from a very similar method inside of C++. Next, inside the parentheses, you put in these things called parameters. And what parameters are little bits of data that the method needs to know in order to do its job. So if you call printline, but forget to say what you want it to print, it doesn't really work that well. It'll just print a blank line, which isn't that useful most of the time. So the string up here, hello world, is the parameter into the method printline. An easy way to remember this is you say, first you list the object, then a period, then you say the method, and then an open parenthesis and a closed parenthesis. If the method takes parameters, you put those inside the parentheses. If the method doesn't take any parameters, you still need the parentheses, but you just leave it blank. So that just that single line of code, there's a lot going on. You know, we're hearing this method, and all of a sudden there's all this stuff. Don't be too concerned that this is not making a lot of sense right now. I'm just showing all the different pieces, and we'll learn at a pretty leisurely pace here at the start what all this means. I know for a lot of people this is the first time they've had to deal with writing in a language that's so specific. Truthfully, the Java language only has 45 words in it. Just 45. So that's not a very big vocabulary, but it's amazing what you can do with those 45 words. Here's our first syntax card. As we go through these, and I don't have enough cards for today, I'm going to have to go get some of it. We're going to make little flashcards that have these syntax cards on them, so you can refer to them. Say you're writing some code and go, I need to do a method call. You go find your method call card, and you'll have this information on it. The formal syntax is up here, object.method name, parameters, but for a lot of people, that doesn't make a lot of sense. It's better to see an example. So here's our example. Here's the object, here's the method, here's the parameter passed in. Now I was talking to some of the computer scientists that came up with this word method. I've actually met a lot of these people. This is like history for me. Strings are kind of a strange word. You could expand it to say strings of characters. I always imagine a string as being, sometimes you make garlands during the holidays. You take popcorn and maybe a thread and needle, and you push it through each popcorn thing, and you can make a nice garland of popcorn. That's the way I look at strings. Strings are like, instead of popcorn, you'd be using letters. So hello world is a string. Basically, it's just a sequence of characters surrounded by double quotes. So here is hello world. You could imagine a string holding all these letters together. So when I say string, what I mean is a string of characters, string of letters. How do you show a string of letters in Java? You put double quotes around them. The opening quote tells you where the string starts. The closing quote tells you where it ends. The stuff in between is the actual string itself. So hello world is a string. So here's some self-checks. How would you modify the hello printer program to print the words hello, comma, and then world on 2 lines? What you could do is split these strings up and print them, call print line twice. I think that's what they're saying, yeah. If you want them on 2 separate lines, you would just call system.out that print line twice. Print line means print this and then go to the next line. There's another method called print, and that prints it out but doesn't go to the next line. So the next thing you try to print will be right next to the thing you're at. But if you want hello and world to be on separate lines, then just make 2 calls to the method print line, and it will print out hello and then a new line and then world. So would the program continue to work if you omitted the line starting with the 2 slashes? Remember, the slashes represent the start of a comment. And remember, the computer doesn't care about comments. So you could leave that whole line out and the program would still work, because all you did was you took out the comment that was intended for human readers. The compiler ignores comments, so the program would still work. But the person 12 years later trying to modify the code will be cursing you, because now I don't know what it's doing. So there's two audiences when you write code. The first audience is the compiler. That's a very difficult thing to keep happy. But the other audience that you're writing software for are humans that go in and look at the code and change it, modify it, make it better without breaking something else. Okay, here's another self-check. What does the following set of statements print? Yeah, so this is kind of a challenge. Let me go up front. Okay, so this first one here, print. Notice it doesn't say print line. I think I mentioned that. When you call print, it'll print that thing, but it won't advance to the next line. Okay, but then the challenging one is here. Notice that it's the 3 plus 4 plus 5 is not in quotes. Because it's not in quotes, that means it's not a string, which means the compiler will see that and go, oh, those are numbers. So what it does is the compiler sees those numbers and adds them together, and then it sends that out to the output window. And so you should get, let's see, 7 plus 5, 12, right? Yeah, so you get something that looks like this. My lucky number is 12. But you see the problem. There's no space between the word is and the number 12. So if you're really coding this, it would be a good idea to add an empty space right after the word is, embed that into the string above, and then when the 12 comes out, then it looks a little bit better. All right, so how do you edit a Java program? Okay, so this is just a text file. If you took web design, we just used Notepad++ to make the HTML. This is the same stuff. You can just use Notepad to write Java programs. There's nothing really fancy about that. So any text editor will do. You have to be careful with Java because Java is case sensitive. What does case sensitive mean? Well, it's like capital letters and lowercase letters. If you put a name out there that has a mix of capitals and lowercase letters, and then maybe the same name but everything in lowercase letters, those are not the same. Those would be treated differently by the Java compiler. There are some languages where that's okay. You don't have to capitalize correctly. Not so in Java. So when someone says it's case sensitive, that means an upper letter or a capital M is different than a lowercase letter m. It will be treated by the compiler that way. Another thing you want to do when you're programming Java is you want to lay out your programs so that they're easy to read. Again, there's two audiences. There's the human audience and the compiler. So for us mere humans, you need to lay out your program in a consistent fashion. Make it easier to read. So there's this concept of compiling and running. And all these new terms, it's so hard to talk about programming without having this huge vocabulary hit you on the first day. So I apologize for all these rather abstract words that we need to define. All right, so the Java compiler, what a compiler is it takes the code that you typed in and turns it into instructions for the Java virtual machine. Okay, so let's pull this sentence apart. The compiler takes the source code, that's what we were just talking about, the typing that we put in the class files, and turns them into commands to the Java virtual machine. Yeah, so the compiler translates source files into class files, contains the instructions for the Java virtual machine. The Java virtual machine, remember, is this mythical machine that lives inside your computer that you're writing software for, but it doesn't actually exist. Each platform implements the same machine, basically an emulator. If you ever played like one of those Nintendo 64 emulators where you can play games, Nintendo 64, right there on your PC, that's kind of cool. But you don't really have a Nintendo 64. So it's the same setup here. We have this Java virtual machine. The only thing different is there is no Java machine. There is no Nintendo 64. So you're emulating this one machine that doesn't exist. But it still works. I used to have to write emulators. Really quite difficult. Okay, so what the compiler does is it takes the .java file and converts it into a class file. And it's this .class file that has all the Java commands in it. It's called Java bytecode. All right, so here's our application. Here's our program. So I'm going to go look actually in the folder where that resides. Here's the trick. If you're trying to figure out where something lives on the actual hard disk, you can do a save as, and it shows you where it's at. Right now mine is, it's right there in my Z drive root folder. Okay, so if I go out to my Z drive now, yeah, here's the file. Here's our source, and it sees that it's a Java file. So it has a .java extension on it, even though you can't see that. Here's the class file. So this is what gets generated when I compile the program, this .class file. What does it look like? Yeah. Doesn't make any sense at all. To a text editor, it's just a bunch of junk. It's trying to interpret as a program. You see, every once in a while you see a little bit of text that's understandable. But for the most part, from a human point of view, it's been translated into a language humans can't understand very well. And this is a mess. But realize the class file is not for you to read, it's for the Java virtual machine to read. The Java virtual machine will look at this file and go, oh, I know what to do. And it'll print hello world up on your screen. If I go in and erase, I'm going to erase that class file. Just delete it. And then go into NetBeans and recompile it. So I compile it again. Okay, so it says hello world. If I go back then to that directory, you see that our class file is back. Okay, so that's what the compiler is doing. It's taking that .java file and it's turning into this class file that the Java virtual machine can run. And I'll try to do this in the lectures, so I'll switch over to the compiler. You know, they talk about stuff on the screen, but you really have to see it to understand it. So I'll try to do that during this class. So what does the Java virtual machine do? It loads the instructions for the program's class file, it starts the program, and also loads the necessary library files that are required. That happens at the beginning of every run. So who says you have to use NetBeans to compile your program? You really don't. Everything you need for compiling Java is available on the command line. If you look, like for example, this next slide, you can be in the command window on a PC or maybe a console window on a Linux box like this is. You can call javac, which is the Java compiler, send in the .java file. It will create a hello printer.class file. And then to run it, you just say Java hello printer. And it will run the class file. And you'll see this on the command line. So you don't necessarily need that big fancy IDE. You can do everything you need to do to compile Java programs just right there in the command window. In fact, ultimately in the NetBeans, eventually gets down to an internal command window and runs it this way. But we're using NetBeans. Typically, you have your source files over here. Here's the picture in the file where you do your typing. Here's the output window. If we look at NetBeans, then same kind of setup. Here's your source code files. Here's what you're editing. Here's the output window. All right, so we'll stop there for today. I know that was a lot on the first day, so I don't want to overdo it. Do you have a specific assignment right now? I would suggest maybe getting a start on the first couple pages of chapter 2, and that's where we'll really start getting into what makes Java tick.